Hello class, welcome to Pre-Algebra Lesson 210, which is all about operations with numbers in scientific notation. By the end of this lesson, you should be able to perform operations with numbers in scientific notation. So let's jump right in. We are going to begin with adding and subtracting numbers in scientific notation. So first, I'm going to show you what's going to be a very annoying way, but just to help you visualize and see what is happening. And then I'm going to show you the shorter way where you're going to be less likely to make mistakes. Okay, so the first thing I'm going to do is I'm actually going to move this over a little bit. So this first way, I am looking at the mass of Earth and the mass of the Moon are shown. How much greater is the mass of Earth than that of the Moon? So how much greater means that I need to subtract, right? I'm going to say Earth's mass minus the Moon's mass in order to determine how much greater the Earth's mass is. So let's start with writing out what is the Earth's mass, it's like a tongue twister, in standard form. So I have 5.97 times 10 to the 24th. So 5 is the only number that is already in front of the decimal point, right? So I'm going to count to the number 24 as I write out 9, 7, and then all of those zeros, right? So I'm going to have the digits 9, 7, and then 22 zeros. Okay, so 5, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and I'm just going to double check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, so I know I wrote out the Earth's mass correctly. Now let's write out the Moon's mass. So it's 7.35 times 10 to the 22nd. So again, I would do the same thing. This time I see it's a slightly smaller number, and it's smaller by 2. So I'm going to start right here, and I'm going to say 7, and then count to 22. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And I can double check that work. I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I know I did that correctly. And now I could subtract, right? If I look at everything after this 5, it's all zeros, right? So I would have all of these are going to be zeros. So that's a lot of zeros right there. I believe that's 20 zeros. All right, and then I would need to subtract. And this is where, if you want to start using your calculator, go for it. What I would type into a calculator is I would just get rid of those zeros for now, and I would say 59700 minus 735. Okay, and when you do that, you should get, let's see, it would be this number right here. If that is not the number that you got, please let me know, or double check how you typed it into a calculator or whatever it is you did. Okay, so you can see I have this really long big number, and I would have to figure out how to write it in scientific notation. So just like we talked about yesterday, the decimal has to go after that first non-zero number. So I'd have 5.8965 times 10 to the, and then if I were to count all of these, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So you can see the Earth's mass is 5.8965 times 10 to the 24th kilograms bigger. Okay, so I would say Earth is, excuse me. So as you can see, that's a really annoying way to do it, right? Having to count out all those zeros. Also, it leaves a lot of room for error. So the way that I want you to practice doing it is going to be what I'm about to show you. I just wanted to help you see what was happening, okay? So really what I'm doing here is I'm saying the Earth's mass minus the moon's mass. And right now, the Earth's mass is written as 5.97 times 10 to the 24th, and then the moon's mass is 7.35 times 10 to the 22nd. Now, if I think back to our lesson 2.6, which is the first part of chapter 2, part 2. Okay, so in my class, we split chapter 2 into 2 parts. Now I'm going back to that first lesson in that second part, okay? So 5.97 times 10 to the 24th minus 7.35 times 10 to the 22nd. If I look at this, it's nothing quite like I've seen before, but I have the ability to change something in order to make it look like a pattern I saw from that very first video. So what I mean by that is we had learned, I'm going to do a little side note down here. We had learned, like, if I had, what was it? I think it was 2 to the third times 12 to the third. We learned that we could write that as 2 times 12 to the third, right? Because our exponents were the same. Same thing goes for subtraction. If our exponents are the same, we can do that same process. So what I'm going to do is I'm actually going to change that 24 to a 22 by moving the decimal. Okay, so in order to get rid of 2 of those, I would have to move my decimal. I'm going to make sure I have a different color. I would move it 1, 2. So I would now have 597 times 10 to the 22nd minus 7.35 times 10 to the 22nd. So do you see how me moving that decimal point made it so my exponent changed to match? That's exactly what we want to do, because now I can say what is 597 minus 7.35 and then say times 10 to the 22nd. 597 minus 7.35 is going to be 589.65 times 10 to the 22nd. But I see this and I think to myself, well, I can't have 589 be part of my decimal, so I'm going to move it, and each time I move it to the left, I'm going to add 1 to my exponent. Right? So my new answer is 5.8965 times 10 to the 22 plus 2 is 24. So this would be my final answer. Okay, so I know adding and subtracting like that can take a little bit of time to get used to. So if you have questions, please ask for help. I am more than happy to help you, okay? But I want you to see if you can try this problem on your own. I am going to help out a little bit by drawing just a little diagram, okay? So we have the planet Venus is on average 2.5 times 10 to the 7th kilometers from Earth. The planet Mars is on average 2.25 times 10 to the 8th kilometers from Earth. When Venus, Earth, and Mars are aligned, what is the average distance from Venus to Mars? Okay, so just to help you out, Venus is closest to the sun out of those 3. And then we have the Earth, and then furthest away is going to be Mars. Okay, so this is important to know, so that way you have an idea of what it is you are actually looking for. So with that in mind, we know that the distance from Venus to Earth is 2.5 times 10 to the 7th, and the distance from Earth to Mars is 2.25 times 10 to the 8th. So why don't you go ahead and figure out, like, what is that total distance? So think about it. We're going to add this time instead of subtract. Good luck. All right, for this problem, hopefully you said or got 2.5 times 10 to the 8th kilometers as your answer. You can take a look at my work there. I was able to take the distance from Earth to Mars, and what I did was I moved the decimal so that way my 8 changed into a 7, which allowed me to just add my 2.5 with my 22.5, which gave me that 25 times 10 to the 7th. And then to move that decimal point over 1, I would increase my exponent. And that's how I got 2.5 times 10 to the 8th. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. Let's move on to example 2. In example 2, we are going to practice multiplying numbers in scientific notation. So what we have here is the Confederation Bridge connects New Brunswick to Prince Edward Island in Canada. The main part of the bridge rests on piers that form 43 segments. What is the approximate length of the main part of the bridge? Express your answer in scientific notation. So we can see from the image the distance between our piers is 8.2 times 10 to the second feet. So 8.2 times 10 to the second. And I know I have 43 segments. So what I'm going to do is I'm actually going to take 43 and I'm going to write it out front just so that way it's a number that doesn't have an exponent being multiplied with a number that doesn't have an exponent. So you can see I'm leaving that times 10 to the second alone. And what I'm going to do is I'm going to use my calculator because we're allowed to do that now. And I'm going to say what is 43 times 8.2. And when I multiply 43 times 8.2, I end up with 352.6. Okay, so that's what happened right there, 352.6. And then I still have that times 10 to the second. And I'm really close to having my answer in scientific notation, but I can't have 3 numbers in front of the decimal, so I have to move it 1, 2 spaces, so I know I have to add 2 to my exponent. So I have 3.526 times 10 to the 4th. And that right there would be my final answer. Well, almost. I would also want to say feet, because we're talking about distance here, and labels matter. If you have questions about that, please be sure to reach out for some help. I am happy to help you. But let's talk about example 3 next. Dividing numbers in scientific notation. So now we are talking about a queen ant. She lays 1.83 times 10 to the 6th eggs over a period of 30 days. Assuming she lays the same number of eggs each day, about how many eggs does she lay in one day? Express your answer in scientific notation. Okay, so in scientific notation, what we can do is, I know that this is my total, right? I'm going to take my total, which is 1.83 times 10 to the 6th, and I am going to divide it by the days here, because then that would tell me how many per day. So I'm going to divide by 30 days. But something I meant to do on the last problem but definitely forgot, so I'm going to make sure to do it here, is let's convert 30 to a scientific notation number. So that would be 3 times 10 to the 1st, right? Because I just have to move it 1 spot. So I'm going to say 3 times 10 to the 1st. And the reason that matters is now what I can do is I can take those 2 numbers and I could say, what's 1.83 divided by 3? So I'm taking these numbers and I'm dividing them like normal. Okay, so dividing like normal, and I end up with 0.61. And then I'm going to say times, and then 10 to the 6th divided by 10 to the 1st. Remember, with division, you subtract your exponents, so 6 minus 1 would be 5. And the last thing I have to do is just make it into real scientific notation form, right? I have to have this decimal after a non-zero number. So I'm going to move it to 6.1. But do you see how this time I'm moving my decimal to the right? When I move it to the right, when it's already in scientific notation, I need to subtract 1 from my exponent. So now I have 6.1 times 10 to the 4th. And my label would be eggs. Okay, so 6.1 times 10 to the 4th eggs is how many eggs the queen ant lays each day. And just for practice, let's convert that to standard form. So I have 6.1, and I would move it 4 decimals, so I'd move 1, 2, 3, 4. The queen ant is laying 61,000 eggs each day. And the reason I converted that to standard form is because that fact blew my mind, and I just wanted to share that with you. All right. Before I actually move on to the question for you to try on your own, I do want to make a slight adjustment to this problem right here. So instead of saying 43 times 8.2, what I'm going to do is I'm going to convert my 43 into scientific notation just to practice and show you. So instead of 43, I would say 4.3, and that would be times 10 to the 1st, because I only had to move the decimal 1 place. And then if I were to do that, that would give me 35.26 times 10 to the, I would add my exponents this time, 3rd, and then if I were to move that decimal, 3.526 times 10 to the, since I moved it to the left, it would be plus 1, so 4. So you can see that's another way that you can get to your answer. And then I did the same idea with the division, just had to subtract my exponents, and now I want you to try this problem on your own. There are 1 times 10 to the 14th good bacteria in the human body. There are 2.6 times 10 to the 18th good bacteria among the spectators in a soccer stadium. About how many spectators are in the stadium? Express your answer in scientific notation. Good luck. Alright, for this problem, hopefully you did the total divided by the part, and you had your work that looked like this, and then 2.6 divided by 1 is still just 2.6, but 10 to the 18th divided by 10 to the 14th is 10 to the 4th. If you have questions about that, please be sure to reach out and ask some questions. I don't know what's with my brain today, but I keep forgetting to label, so I would label this one, people. All right, the last slide here is the key concept page. Feel free to use this to help you remember all of those different rules. If you have questions about anything, please be sure to reach out for some help. I hope you have a great day.